Right, so it seems everything seems to be working, and I hope that is the case. But it's 5 o'clock. It's time to begin. So welcome to this live stream demo of Gren 03, which is to be released this Monday. We're going to be talking about everything that is new since Gren 02, which was released in December. We're going to go through some live coding exercises. We're going to show a demo of how you can do testing and how to structure applications for testing. And after that, we're going to go through a demo on how you can debug applications using the new Sourcemap support in Gren 03. When I've shown those things, we're going to talk about Gren 04 and what's in store for that. And finally, just a plead for people to come help us out develop the language further. So with that out of the way, what's new since Gren 02? And I'm saying what's new in Gren 02 as opposed to what's new in Gren 03 because there was actually an interim release in March, I believe, that contains half the features that were originally slated for 03. And I didn't do a live stream of 021, which the release was called, so I'm kind of covering it in this stream. One of those features was local dependencies, so you're now allowed to point your project to a folder on disk containing some dependency, which is great for testing a release before you make it publicly available. Gren also has a test framework now, which is based on the official test framework in Elm. And the new feature of Gren 03 is Sourcemaps, and Sourcemaps enables debugging of actual Gren code in the Node.js debugger and in the browser. In addition to those things, there have been a few quality of life changes to the core package, mostly the Node.js package. Makes code a little bit easier to write. And with that, let's just jump straight into demo. So here I'm in the core package, Gren's core package, and you will see that it has a new test folder in addition to the source code for the package itself. Now, if we look into the test directory, we can see that there's another Gren application there. So let's see how that's formed up, or how that's made up. So if you look into the Gren JSON, we will see that it's just a standard node application. But what's interesting here is that it relies on a local dependency, or more specifically, the dependency being one level up the tree, which is the core package. So the test for Grenlang core is just an application, just a node application that uses the core package as a local dependency. The actual test framework is a dependency, and there's a node test runner that's run as a dependency. In theory, you could have a browser test runner if you're going to try to debug browser applications or browser packages. But that hasn't been built yet, so so that's not possible at this moment in time. And then if we were to look at the actual tests themselves, they look pretty much like, well, if you ever use the test framework in Elm, they look exactly the same. It's the exact same code. The only difference is that we don't auto-generate code for you, so you have to create a tiny set of setup yourselves. Just gonna add some syntax highlighting here. So, but essentially the way it works is that you can describe a test suite, and then you create some tests, that has a name or a description of the test, and then you provide the actual test itself here. It's relatively straightforward, but of course the Gren test framework, just like the Elm test framework, has quick tests style testing possible through fuzzers, allowing you to generate test code and do testing on properties of that. So really, so the way we run these tests isn't really any magical. We compile the test application and then we run the test application. And there's the test run is passed. If we want if we want a failing test for this, we can do that just to see that it does in fact work out okay. There you can see 3 tests failed. Seems a bit odd actually. Yeah, but that's because it runs more than one time in this particular case. So that's all testing really is, right? You create a new application that references the code you want to test as a local dependency, meaning it's a dependency that resides on your disk. And then you compile it like a regular Node application, and then you run it as a regular Node application. And it's not much harder than that. But that poses an interesting question, like how are you supposed to test code in general? So if you have an application, say, an application isn't something you can import into another application, and so local dependencies doesn't help you there. But the idea here is that when you create a project, that you separate the business logic into a package, and then you have an actual application that relies on that core package, or the business logic package, to be able to actually make that something that can be run. And then your test would just be another application that references that package and can test it instead. So that was a brief note on testing and the test framework and how all that stuff works. One of the new features of Gren 0.3, which is going to be released on Monday, is Sourcemaps. Sourcemaps is a web API or a web specification that allows you to define a blob of JSON that essentially teaches the browser how some set of compiled JavaScript relates to some set of source files. I think it's best to explain this through an example. So here I am in the cat example project that you can find in the example projects repo on GitHub. And we're just going to compile this using the latest version of the compiler. We're going to compile this program like normal. We're going to run it and pass in some file that the cat program will output to terminal. Nothing fancy. What if we were to do this, right? We would get an error. Now, sometimes, I don't know, I'm just making up silly examples as I go, but let's pretend for a moment that we would like to debug this application. Like, how does this application actually work? How are we getting to certain states of the program? So in the latest version of Gren, you can pass in a source map flag, and that will inline source mappings into the generated output. So just to show some numbers here, if we were to compile it without source maps, you will see that the application file is around 128K. If I do it with source maps, you will see it increases by about a third. And that's because, source maps or debugging information in general is adding a lot of stuff to the compile output. And if you want to see like how it looks like an emerald thing, but we've added some stuff at the bottom here, which is a huge, which is a base 64 encoded JSON, and the JSON that is encoded is actually quite big. But everything above this line is the same as it was before, more or less. I'm just gonna compile once more. Another thing to note about the source maps is that if you are compiling your application through something like Webpack or Parser, those tools do understand source maps. And so even if you want to apply minification to this stuff, in theory, I haven't tested it, but in theory, tools like Webpack, Parser, or whatever, Parcel, should be able to understand the source maps and remap it so it matches the minified output. Again, haven't tried it, but in theory, it should work. But let's say we want to debug this, right? So we have a node application written using Gren. We want to be able to debug it. So we're going to run the application just as we did before. And as you can see, we'll give the exact same output as it did before, but we can run node with this inspect command. And then it will start the application, but then stop at the first line of execution and wait for you to, well, start the debugger. So now we've started the application in debug mode. And an interesting thing about Node is that once you do that, Chrome-enabled browsers will actually be able to pick it up. So if you go to a Chrome-enabled device like this, you can simply do go to this URL, chrome://inspect. You will get this window, and then it will pick up your application, and you can click inspect. So here's the application, and this is the debug. This is the generated JavaScript code for the cat program. But if I try Command P, then it will allow me to search through, well, anything that's possible. And you can see a lot of Node internal APIs here, but I can actually go to the main program like this, and this is the source code of the cat program. You can see I've already placed some breakpoints already here, but that's entirely possible. I can also, if I want to, like if I was calling some API and I wanted to see, or calling some module and I wanted to see what happened in there, I could also go to that. So to the task module, for instance, and this is the source code of the task module. So if I were to debug anything in here, then I would be able to. I can set breakpoints in that code as well. Well, let's go to the main program of the cat example project, and I'm just going to set a breakpoint at the point where we're going to evaluate if we can run the program based on the number of arguments. And the interesting thing you can see here is that when I set a breakpoint in this line, I can actually choose where specifically the breakpoint will be. In this case, it doesn't really matter, but it does tell you that Chrome actually understands a relatively large amount of stuff concerning this code. But we're going to set a breakpoint, and we're going to continue execution, and then we've hit that breakpoint. And you can see that in the node config variable, these are the variables in it. And if we hover over args here, we will see the value of the arguments array that's passed to the program as it begins. And you can see that we passed in gren.json as the input to this command. And I think if we step through this, then we eventually get to the line that's supposed to be called when everything goes well. And if you hover over the variables, you will get an actual explanation of what those things are and do. Of course, I can, the thing that we do, the cat program, it receives a file from the input, and that's gren.json in this case. But we can, and the next thing we'll do with that is try to open the file for read access. That's an asynchronous command, so that will happen in the update function. And so we can actually set a breakpoint here just to make sure that it actually gets where we think it will. We can run, and it does turn out we can go here. And then we can see, we can inspect what the model is, what the message is, what the file handle is. No, that doesn't seem to work. But we can inspect, most of these things, and we can see on the left-hand side here the potential values and what their states are. And of course, we can just make sure that we actually get to the point where we output to the terminal the final result, which we do. can even see the actual bytes and drill down into it if you want to. Here you can see Chrome's thing. You can actually see the JSON that it's gotten in. So this actually allows, like, enabling Sourcemaps actually gives you everything you need to be able to debug this to the same level as a JavaScript project. Well, almost to the same level. Like, I assume that there are improvements that can be made through source mapping support here, but I think this is a pretty good first step. And of course, and I'm going to run the program, and it starts, stops, and outputs this thing. Of course, this was a Node program, but you can do the exact same thing in a browser program as well. So here we're going to do the exact same thing. And then we're going to open index.html because this is a browser project. There we go. So this is the, the standard counter application. You can click this button and then the counter goes up. But if you open the DevTools, you can also here see the source code of the actual application. You can set a breakpoint where you want to set the breakpoint, and then it will in fact stop, and you can inspect the model, which is 0. Yeah, not the most exciting example, I know, but it does in fact work. So that was a demo. The theme for the last 6 months have been testing and debugging, and in my opinion, Gren has delivered on that with this Monday's release. So with Gren 03 out of the way, what's the plan for Gren 04? And the big feature of Gren 04, which is to be released in December, is to add parametric modules. Now, before we talk about what parametric modules are, we kind of have to touch on the problem they're meant to solve. And the problem is that of flexibility. And to make that a little bit more concrete, here is a screenshot from the implementation of dict-get. So this is the function you call when you want to retrieve something from a dictionary in Gren. And you can see a couple of things, but most specifically, you can see this comparable annotation here, or the comparable type, which, since it's a lowercase letter, it should mean that it's generic. But in Gren, and Elm for that matter, comparable is kind of like this magic type variable name that means that no, you're actually having something that is comparable. And comparable in this context means that you can call the compare operation on it, or the compare function on it. And to be able to have a dictionary, you need to have the notion of comparability. So the Gren dict is a sorted dictionary, so you have to be able to sort over something, but you also want the keys to be work on not just one kind of value. And so that has been a way of solving that, to just say that we have this magic comparable type annotation thing, and whenever you say that, then you are actually getting something that is comparable. But there's no way to implement a comparison implementation. Like, you can't say that for my custom type, comparable means this. That's not possible in Gren. And so you're kind of locked down to what I believe should be comparable. And if you want to use, like, if you want to create something similar, like a hash map, then you can't, because you don't have the flexibility of adding stuff like this. And that's something that I think should change. Another problem with this approach is that if we're going to target WebAssembly in the future, then that's going to be a big undertaking, simply because the current implementation is actually based around JavaScript. That when you're running JavaScript, we can actually do checks to see what kind of type this is. You can do the same thing in WebAssembly, but that does dampen how we do code generation and the sort of stuff that we can do. So for the future of Gren and for being able to define the code that you want, we need to fix this problem somehow. There needs to be a way of writing code that isn't bound to a concrete type. Or right, and that's useful. Otherwise, we wouldn't have this magic syntax in the language today. But the magic syntax has its limitations, and so we need to find like a good solution to that. The common solution to this is interfaces or protocols or type classes. They're essentially, they work, at the core, they work in similar ways, where you define a contract that says that something is comparable if you can run it through the compare function, and then on a type-by-type basis, you can say that, well, if you run this through the compare function, this is how it should work. And it does work, it's the most common thing, but I'm not entirely convinced it's the best way to go for Gren. There are a couple of reasons for that, but the most significant one is that if you're creating something new, like my string, which is not the same as a string, and then you implement the compare function for my string. If you at any other time, for any reason, wants to implement a different version of compare for my string, maybe you want it to work slightly differently for debugging or in certain tests, right? Maybe in a certain test you want to override how comparison works to ignore some aspect. Or actually, when I work in the compiler for Gren, sometimes it would be nice to have a version of equality that actually ignores code positions, for instance. Because, the position of the code doesn't really matter, but it might matter in certain contexts where I want to see, are these exact similar? But you can't have that because the implementation of an interface for a certain type is global. And so if you have an implementation, you can't at some other time override that implementation. There are workarounds to this, like you can wrap the type in some other type and then do the implementation on that type. But it's not, but then you lose all the aspects of it being that original type. Like you're creating something new and perhaps unwrap it in order to have it working elsewhere, but you're essentially just adding duct tape to fix a problem. Another thing about interface C type code is that it requires runtime computation. Like you're essentially saying, I don't care what this is, but at runtime I will figure it out. That does have some overhead, not a lot. JavaScript is pretty good at that sort of thing because you do that a lot in JavaScript. But that's another thing to keep in mind, is that you can't necessarily optimize something because you don't know what it is until you actually run the program. And interfaces are very, they're very flexible. You can make use of them in a lot of situations. There really isn't a limit to how much you can use interfaces, and that has led to them being used a lot. And I think in general they are overused. And I think if you worked with Gren or Elm, then you've come to the solution that it's actually quite nice to know exactly what concrete type you're working with. And I don't want to introduce a language feature that makes it easier to program against abstractions. I want you to program against concrete things. And as an effect of all of this, when you're dealing with interfaces, there's a limit to the sort of error messages that you can create, because you have to deal with the abstract. You have to deal with the fact that you don't necessarily know what type it is. I think if you were to know that more, then you could get a lot of error messages. Again, this is something I think Elm has proven. Yeah. So the chosen solution for Gren is parametric modules, and that's what we're going to try to implement over the next 6 months. And it looks pretty much like this. So if we're going to create a dictionary, and we want to be able to give the user some flexibility on what type is serving as the key of that dictionary, then we can do as following. We can define a module, and we can say that this module, in order for this module to be used, it requires that the user passes in a comparable, which for the purposes of this code, we're going to reference as key. And then you can expose, whatever you want. And the way you use this comparable, in fact, I'm just going to show you what the comparable is. So a comparable is a module. It's a special kind of module called a signature module. And comparable only contains type definitions. So we are saying that a module is comparable if it has a type alias t, and it has a compare function that works on t to return an order, and that it has an equal function that takes in two t's and returns a boolean. If a module has those three things, then it's a comparable, and you can pass that module in to modules that requires such a module for execution. So that's what, comparable is in this particular case, and you can define your own signature modules. But in this exact example, comparable just means that it is a module that has a type alias t and a compare function and an equal function that operate on that type alias. And then when we define the rest of the dictionary, we're saying that a dictionary is either empty or it has a key and a value and a left and right subtree. And the key in this case is the comparable and the t type alias that resides within. So if you pass in a string to this dictionary, then the key would be a string. If you pass in the int module, then the key would be an integer. If you pass in you could probably do this for arrays as well, right? If you pass an array, then, node would be an array. And then for the get implementation of actually getting this out, you will take a target key, which, for string would be string, and then a dictionary, and then you return maybe some value. And then, if the dictionary is empty, then you return nothing. If it's not empty, then you compare with the string implementation of compare with what is stored in the dictionary, and then you either return the value. This is wrong. It should be node value here. Or you go searching the left subtree or the right subtree, depending on, the order of the type. And then at the use site, you would simply import dict as a string dict if you're sending a string. Or, you could pass in anything else that meets the requirements of being a comparable module. So how is this? Well, this is something that works. It works in a way that implementations don't exist in a global namespace. And it does so by requiring that when you import a dictionary, that you specify what this is a dictionary of, right? If you want to have two dictionaries, one where the keys are strings and one where the keys are integers, then you have to do two imports, and you have to rely on those two things, or you have to specify, essentially, which particular type of dictionary that you're working with. And this doesn't require runtime computation, right? At compile time, we know what specific implementation of dict that you're using. Which means that, in theory, it runs faster. There's no dynamic thing being involved here. And it's easy to provide concrete error messages because we know the exact concrete types that are involved. The problems with this is that, it requires a little bit more typing because you have to explicitly import a specific implementation of something. And that means that you don't really have the flexibility to mix and match a lot of dynamic code, as much. But again, I realize that we need some flexibility in how we define certain types of data structures, but I don't want to give you too much flexibility. I like that people work against concrete types. And so that actually suits us pretty well. So just, to bring up an example, in Haskell, you do a lot of abstract programming, like you're working with monads and I don't know, the monads was the first thing that comes to mind. But in Gren, defining a monad won't be the easiest thing, because implementing a monad doesn't really give you anything. If you're gonna do like monading things, you're gonna have to import stuff specialized over a module constantly. And so if you want to work on like the abstraction level of a monad or monoid or stuff like that, that's going to be an uphill battle, and I don't think you would want to do that. It's just painful. But for the specific use case of I have a data structure and I want this data structure to work with any potential type, as long as you can define a compare function for it, then I think this is a very straightforward way to achieve that. So that's like the big thing for Gren 04. There are a couple of other things we're working on, the most important of which are APIs. So these might be available before the release of Gren 04. So Justin Blake, a member of the Gren community, is working on HTTP server API. He's well on his way here. If you want to provide feedback on that work, then join our Zulip channel and check it out. And in addition to that, I'm also working on an API for spawning child processes for Node applications. So in theory, that means that you can write a Gren application that shells out to get, and then you can process the return value and present that in a nice way or something. Just providing an example, you can do a lot of stuff with that sort of API. And I'm hoping to have that finished sometime over the summer, perhaps. So that's, that's what we're working on for the near future, and that's what we've been working on for the past 6 months. I would love for people to check this out, try to use Gren a little bit. And if you want to help us create Gren, then you could help us out by simply using it, reporting bugs, provide feedback, maybe talk or write about Gren to other people. Or you could create packages. Like one thing that I would love for people to make would be like a command line argument parser thing to make it easier to create like more complicated CLI apps. And if you're feeling particularly bold, then do what Justin did. Just say, hey, I would love to see like an HTTP server API for an Elm-like language. Is it cool if I experiment? Normally that's completely cool. Just reach out to me on Zulip and we can talk about it. And if you're not able to do any of these things, but you love the work that I do on Gren, then do consider sponsoring me on GitHub. The plan is to kind of like save all the money that I've been sponsored with, and in the future maybe sponsor a conference or sponsor some part-time work or anything. So do consider that as well. That's all I intended to talk about.